All right, welcome to our lesson on compound statements in geometry. Hello, Gary.
A compound statement is a statement made of two or more other statements. A conjunction is an and. It's used with the like upwards or upside down V, I guess you'd call it. It's said S and J. They are only true when S and J are both true. The counterpart of a conjunction is a disjunction, and that is an or statement. It's represented with a V-looking thing, and basically read S or J. It's only false. It can only be false when S and J are both false, and it's always it's true when either S or J are true.
That was Gary. Did a great job. Now let's look at this. We have S and J, S or J, S or J and T, S or J and T. That's how we read those. And I've given these conditional statements. Students will construct an angle. Students will construct a bisector. Students will complete homework. And let's see what this says. This says S. Students will construct an angle and they will construct a bisector. So this one right here means they're going to construct an angle and a bisector. This one right here says an angle or a bisector. Now these are a little bit more tricky. This says students are going to construct an angle or they're going to construct a bisector and do their homework. So either students will construct an angle or they will construct a bisector and do their homework. And this one says students will construct an angle or a bisector and they will complete their homework. So the choice is either an angle or a bisector and their homework. And I kind of try and remember the and because it kind of looks like an A, and this one kind of looks like a canoe, and here's your little or, kind of, sort of. It looks like you're paddling your canoe. There's the happy little person paddling their canoe. Now, here we're just having generic. Total S is a true statement, J is a true statement, T is a false statement. So S is a true statement. Whatever that true statement is, a right angle is 90 degrees, doesn't matter. An obtuse angle is greater than 90, it doesn't matter. If I'm saying S and J are together, is that going to be a true statement or a false statement? That will be a true statement because both S and J are true. S or J, that's also going to be true because they're both true, so as long as either one of them are true, it's going to be true. S and T, that's going to have to be false because T is false and I need them both to be true, so this would be a false statement. And S or T, even though T is false, that's funny, T is false. Even though T is false, the statement's going to be true because it's going to say either this is true or that is true, and since this is true, the whole statement is true. Now, the truth tables are not real hard. All we got to do is we put together a table and we put all the possible combination of truth values for two or more statements in that table. And again, to complete a truth table, you must address all possibilities in the statement. So let's go ahead and look at the next slide where we have a truth table. Let's say our question is this. We have P, Q, P then Q, and P or Q. What I have to first think about is assigning a true or false value in every possible combination for P and Q. So P and Q can be both true, it can be both false, it can be true and false, and it can be false and true. Now generally I like to go TT, TF, FT, FF. It doesn't matter any way you do it as long as you're just paying attention. Now let's look at this. We're going to say P and then Q. If P, then Q. And let's see if this is true. Since they're both true, if this is true, then this is true. That means that, in fact, this is true. If we look at P and Q, if both of those are true, then that's true. And if we're looking at P or Q, that's also going to be true as well. So if both of these are true, any kind of conglomeration of those are going to be true. Now, this is where it gets a little bit tricky. False and false. False. If P is false, then Q is false. Well, since they're both false, that's actually, as strange as it sounds, true. Now, here's the problem. P and Q are true. Neither of them are true. So that's going to be false. P or Q are true. Neither of them are true. So that's going to be false. false. This is the tricky one. We have to remember, if P is false, then Q is false. Well, if pigs can fly, then tomorrow is a holiday, and today, it's not a holiday, so pigs can't fly, and tomorrow's not a holiday. That's true. That's one of the tricky little logical conundrums we find ourselves in occasionally in geometry. Let's look at the next row. If one is true and the other is false, this column is going to be false. I changed colors. P and Q are true. No, they were not both true, so that's false. P or Q are true. Well, that's going to be true because this one here is true. Same down here with this one. This will be true, and the others will be false because P or Q or T or Q is true, so that makes it true. But P and Q false. If this is true, then this is true. Well, the first part's not true, so that has to be false as well. Clear as mud, right? If you have any questions, it's just about practicing and working through logical statements.